This is the second in a series of videos on more probability problems. And in this one, what we're going to look at is we're going to look at a problem that we call the general addition property of probability. And the key thing to remember here is you don't double count. It's the only thing you can get wrong here is to make a fairly common mistake. And here's the idea here. This is the formula for the probability of A or B occurring. And the probability A or B is simply equal to the probability of A plus the probability of B minus the probability of A and B. And the reason for this is if you just add up A and B, then you're double counting those which are both. And let's do a simple example using this. Let's use an example of some high school students. So let's say that we have 300 juniors at Thomas Jefferson High School. And of the 300 juniors, let's say 120 of them are taking physics. And let's say 90 of them are taking AP biology. And the question you want to know is what's the probability that a junior takes either physics or AP bio? And what makes this problem a little difficult is some students are taking both. And the key question is how many are taking both? And let's say in this problem 35 take both. Well, in that case, if you think about the probability of physics or AP bio, if you add up the probability of physics plus the probability that you're in AP bio, you would get 120 over 300 plus 90 over 300. But the problem there is if you do that, then what you're doing is you're double counting these 35 that take both, so you have to subtract that out. And that's, I can't do that in my head. That's 210 minus 35. 5, 17, that's 175 over 300. And that's your probability. And the key element here is right here, subtracting out the 35, because if you don't subtract out the 35, you're double counting students in physics and AP bio. Let's do one more example of that. And here's the most classic example of that, and that is, what's the probability? Let's say we're playing a card game, and you win if you get a face card or a spade. And so what you'd like to know is the probability of getting a face card or a spade. And if we just plug in the formula, then that's the probability of getting a face card plus the probability of getting a spade minus the probability of getting a face card and a spade. And we have to subtract that out because if we just add these two, the face card and the spade, we're double counting face cards or spades. And you can see this with a Venn diagram, though you can do it easy enough without one too. You have 52 cards. You have face cards, and that's 12. And then you have spades, which are 13, right? So that's easy enough. That would be 12 divided by 52 plus 13 divided by 52. But the problem is there's an overlapping group here, which are face cards and spades, and there's three of those. There's the jack of spades, the queen of spades, and the king of spades. So there's three overlapping elements there. So you have to subtract out 3 of 52. and that's 25, 22 out of 52 is your probability. Now, in this, I'm going to leave this as a fraction like this. Generally, on a test, you'd probably want to make that into a decimal. You could also do it as a percent, as either one would be fine. And that's the basic addition property of probability. Now, there is a special case. And the special case is when you have something called, you have two events that are called mutually exclusive. And mutually exclusive, the technical definition is simply that the probability of A and B is equal to 0. In other words, A and B cannot both happen at the same time. And in that case, if we apply our formula, the probability of A union B, or A and B, is equal to the probability of A plus the probability of B minus the probability of A and B. But if they're mutually exclusive, that means that the probability of A union B is the probability of A plus the probability of B. Now be careful here. This is only true in the special case when they're mutually exclusive. And sometimes there's some rule that's called like the special addition property or something like that. Now let's be careful just for a second here. If you look at this symbol right here, what does that mean there? This simply means the intersection, so that means and. So I could have just easily say A and B. And what does this mean right here? A union B, I could just as easily have said A or B. And that's the general addition property in the special case of events being mutually exclusive.